Hello everyone. Today we'll be looking into a chemical engineering question from GATE 2021, question number 24. The following homogeneous liquid phase reactions are at equilibrium. So the given reaction system is A reversibly giving B, reversibly giving C, and C reversibly gives A. The values of rate constants are given by K1 is equal to 0.1 second inverse, K minus 1 is equal to 0.2 second inverse, K2 is equal to 1 second inverse, K minus 2 is equal to 10 second inverse, K3 is equal to 10 second inverse. The value of rate constant K minus 3 is dash second inverse, correct up to 1 decimal place. So this is a question from chemical reaction engineering, and the reference for this can be found in module 3 complex reactions chemical reaction engineering by Professor Jayant Modak, Department of Chemical Engineering, IISc Bangalore. So the given system is a cyclic reversible system. So the system is cyclic and the reactions are reversible in nature. And also it is given that these reactions are at equilibrium. For reversible reactions, we can define equilibrium constants. And we can define these equilibrium constants as capital K is equal to forward reaction rate constant divided by backward reaction rate constant. So here capital K1 is equal to small k1 by k minus 1, capital K2 is equal to small k2 by k minus 2, and K3 is small k3 by k minus 3. So K1 is the forward reaction and K minus 1 is the backward reaction for A to B, and similarly K2 is small k2 is the forward reaction of B to C, and K minus 2 is the backward reaction of C to B, and K3 is the same, where small k3 is the forward reaction and small k minus 3 is the backward reaction. So we have been given the values for the small k1, k minus 1, k2, k minus 2 and k3. We need to find the value of small k minus 3. So we'll just substitute the values that we have so far. So we have small k1 and k minus 1 as 0.1 and 0.2. So capital K1, the equilibrium constant for system 1 is equal to 0.1 by 0.2, which is equal to 1 by 2, that is equal to 0.5. Similarly, K2 is 1 and K minus 2 is 10. So capital K2 is equal to 1 by 10, and that will be equal to 0.1. For K3, we have been given the value of small k3, but we don't have the value for k minus 3, which is the value that we need to find in this system. So for cyclic reversible systems in equilibrium, the product of the equilibrium constants will be equal to 1. That is capital K1 into K2 into capital K3 is equal to 1. So we use this concept here to find the value of capital K3, from which we can find the value of small k minus 3. So we have the value capital K1 as 0.1 and capital K2 as 0.5. So K1, K2, K3 is equal to 1. So substitute the values here and find the value for K3. So K3 will be 1 by 0.1 into 0.5, and that will be equal to 20. Now K3 is equal to K3 by K minus 3. We have the value for K3 here, so that is 10, and K minus 3 is the unknown, which will be equal to 20. Solve this equation. K minus 3 is equal to 10 by 20, which will be equal to 0.5. So the required value here, which is K minus 3, is equal to 0.5. Thank you.